We've just navigated the intricate landscape of Descartes' philosophical approach to science and the broader scientific revolution. Now let's zero in on the engine room of his system, his physics. Forget the famous, "I think, therefore I am," for a moment. In his own time, Descartes was a major force in shaping how people understood the physical world. He wasn't just dabbling, he was building a whole new framework, a mechanistic view where everything boils down to size, shape, and motion. We'll unpack how this radical idea emerged, what it entailed, and why it caused such a stir. So, where did Descartes come from? Well, he was steeped in the old ways, the Aristotelian natural philosophy that had dominated European thought for centuries. Think of it as the established order, the physics everyone learned at university, including Descartes himself at La Flèche. The core idea was that things are made of two stuffs: prime matter, which is common to everything, and substantial forms, which are unique to each type of thing and explain its behavior. Why does fire go up? Form. Why do rocks fall? Form. It's a neat system, but incredibly complex, with all sorts of different forms being proposed. Descartes, ever the critical thinker, found this deeply unsatisfying. He even joked about it later, imagining these forms as tiny little homunculi or minds stuck inside objects, directing their actions, like gravity needing some kind of internal knowledge of the Earth's center. Clearly, he saw a problem needing a solution. Now, Descartes wasn't alone in wanting change. There were already plenty of thinkers chipping away at Aristotle during the Renaissance: Platonists, mystics, alchemists like Paracelsus. But the real game changer for him was the revival of ancient atomism. Remember Democritus and Epicurus? They argued that the world is made of tiny, indivisible particles called atoms zipping around in empty space, a void. This was a stark contrast to Aristotle's continuous stuff. Thinkers like Bacon and Galileo were flirting with these ideas. Descartes met Isaac Beeckman in 1618, and this encounter was pivotal. Beeckman was a brilliant amateur scientist obsessed with applying mathematics to physics, acoustics, mechanics, you name it. He basically handed Descartes a toolkit for thinking about the physical world mathematically. While Descartes initially bought into the atom/void picture, this meeting planted the seeds for his own unique brand of mechanistic physics, even if he'd later diverged significantly from Beeckman's views. After meeting Beeckman, Descartes really hit his stride. He wasn't just thinking about physics, he was developing his entire method of inquiry, revolutionizing geometry, figuring out the law of refraction, and pondering magnetism. Crucially, he started connecting these ideas back to metaphysics, realizing that his scientific work needed a solid foundation in understanding God and the mind. By the late 1620s, he had a full-blown system brewing. He was tackling motion, space, body, light, even anatomy, all through this lens of size, shape, and motion. The culmination of this early phase was the world, completed in 1633. Imagine God creating a universe filled only with extended stuff, geometric objects, in the void. Descartes then shows how, through their interactions, they would naturally form stars and planets, and how gravity and heaviness emerge from this purely mechanical process. Even biology gets a makeover in his treatise on man, where he explains the body as a machine, reducing the need for souls in explaining bodily functions. It was a breathtakingly ambitious project. But just as Descartes was ready to unleash his masterpiece, disaster struck. In 1633, Galileo was condemned by the Inquisition. Ouch. This terrified Descartes. He immediately pulled the world from publication and swore off publishing his scientific views altogether. Talk about a plot twist. But as usual, his resolve didn't last long. By 1634, he was already working on a new plan. The result was the Discourse on the Method, published in 1637, along with 3 essays on geometry, optics, and meteorology. Now, here's the clever part. He presented his scientific findings, like the law of refraction, as results, using plausible models without fully laying out his controversial metaphysical system. It was like showing off your fancy car without revealing the engine blueprint. He hinted at his bigger picture in the discourse, but deliberately skipped the juicy bits like Copernicanism and the body equals extension doctrine. A masterstroke of strategic ambiguity, perhaps? The cautious approach of the discourse didn't satisfy Descartes forever. He wanted to lay his cards on the table. First came the Meditations in 1641, primarily a metaphysical work proving God's existence, and the mind-body distinction. It sneakily contained the foundations of his physics. He even told Mersenne, "This contains all the foundations of my physics," though he begged him to keep it quiet initially. But the real flagship publication was the Principles of Philosophy in 1644. This was it, structured logically starting with metaphysics, then moving into physics proper covering body, motion, laws, his vortex theory of planetary motion, magnetism, and more. It wasn't just a translation of the world, it was a refined, systematic presentation of his complete physical system. If you want to understand Cartesian physics, this is your go-to text. All right, let's get to the heart of it. What is body for Descartes? Strip it down to its bare essentials, and what's left is extension. Length, breadth, depth, that's it. For him, we never directly perceive substance itself. We only perceive its properties, its accidents. But among these properties, one stands out, the essence. For body, that essence is extension. For mind, it's thought. All other properties, size, shape, motion for bodies, specific thoughts for minds, are understood through this primary attribute. You can't even grasp the idea of a body without bringing in the idea of extension. It's so tightly bound, he says there's only a distinction of reason between them, meaning they're conceptually distinct, but in reality, they're inseparable. And importantly, things like color, taste, heat, cold, those aren't really in the physical object, they belong to the mind perceiving it. Body is pure geometry made real. Now, Descartes uses the word essence, but don't confuse it with how the scholastics used it. For them, a human being had essential qualities like being rational and animal, and accidental ones like being tall or having blue eyes. You could lose the accidental ones without ceasing to be human. But for Descartes, once you define body as extension, everything else must be understood through that lens. There's no room for properties that exist alongside extension, but aren't reducible to it. His bodies are fundamentally geometrical objects, existing independently in the external world. It's a much cleaner, more unified conception than the scholastic one, which allowed for various properties to be loosely attached to substances. Okay, so if body is just extension, how do we know anything exists outside our heads? Descartes tackles this head-on in his famous skeptical arguments. He argues that we have a powerful inclination to believe our sensory ideas come from external things. Since God is a non-deceiving God, we can trust this inclination. Therefore, external bodies exist. But here's the kicker. The argument proves the existence of a specific kind of body, not the colorful, noisy, tasty world of our senses. What does it prove? It proves the existence of the geometrical object, the thing defined by length, breadth, and depth. So Descartes essentially replaces the rich, sensory world with a simpler, abstract, geometrical one. It's a bold move, sacrificing the familiar for the intelligible. But wait, isn't that cheating? How do we know our idea of body is truly just about geometry? What if there are other properties we haven't considered? Descartes needs to defend this crucial claim. He offers several lines of reasoning, kind of like different angles of attack on the same problem. We'll look at three main ones he uses: an argument based on elimination, one based on the objective reality of ideas, and a more complex argument about the structure of our concepts. Let's break them down. First up, the argument from elimination. Descartes says, think about hardness. Could we imagine a body that isn't hard? Maybe something that just recedes when touched? Yes, he suggests. Could we imagine a body without weight or color? Again, yes. By systematically removing these sensible qualities, hardness, weight, color, warmth, he argues that we can still retain the concept of body. Since we can conceive of body without these things, they can't be essential. What remains essential? Extension. The argument aims to show that extension is the only necessary component of body. However, critics point out a weakness. Just because we can imagine a sphere without redness doesn't mean spheres can't actually be red. It shows extension is necessary, but maybe not sufficient on its own. It doesn't quite rule out bodies having other essential properties beyond geometry. Next, the argument from objective reality, explored mainly in the fifth meditation. Descartes looks at our clear and distinct idea of body. What strikes him most clearly? Its geometrical features, quantity, continuous extension, length, breadth, depth. What's fascinating is that we can perform proofs about these features, discovering new geometrical truths that weren't explicitly put into the idea by us. Descartes then makes a leap. Whatever is true must be something. Since these geometrical truths are in our ideas, they must exist objectively within the ideas themselves. This strengthens the claim that our idea of body includes geometrical properties. But again, it stops short of proving that bodies only have these geometrical properties. It confirms the content of the idea, but not necessarily its exclusivity. Finally, the complete concept argument, which is really the linchpin connecting mind and body. Descartes observes that our concepts aren't isolated islands. Some concepts depend on others for full comprehension. Think about circle. You can't fully understand circle without also understanding figure. Following this chain of dependencies, Descartes finds that all our corporeal concepts, size, shape, motion, ultimately depend on the concept of extension. Similarly, all our mental concepts, thinking, willing, sensing, depend on the concept of thought. The key insight is that the ideas of mind and body are conceptually independent, neither depends on the other for clarity. Since God can create anything we clearly and distinctly conceive, and we can conceive of purely extended substance, body, and purely thinking substance, mind, they can exist separately. Because sensory qualities like heat and color presuppose thought, they involve perception, they belong to the mind, not the body. Thus, physics deals only with the purely geometrical aspect of body. So what happens when you take body equals extension seriously? One big consequence is the denial of the void. Aristotle had said empty space was impossible, and many scholastics agreed, partly due to theological concerns. How could God move the universe if there was nothing to push against? Descartes, however, saw his own doctrine leading to the same conclusion, albeit for different reasons. His logic is tight. Every property needs a subject. Extension is a property. Therefore, extension must belong to some substance, which is body. So, wherever there is extension, there must be substance. A vacuum, by definition, is a place with extension but no substance. Contradiction. He even gives a vivid image. If you remove all the air from a box, the sides of the box would instantly touch each other because there's nothing separating them anymore. Distance requires body. Without body, there's no distance, hence the walls must be contiguous. No empty space allowed. Another casualty of the body equals extension doctrine is the atom. Ancient atomists like Epicurus argued for indivisible, fundamental particles. Descartes, however, saw atoms as problematic. His argument in the Principles is quite neat. Atoms, even if tiny, would still be extended. And anything extended, by the nature of geometry, can be mentally divided. If we can conceive of dividing something, then it must be divisible. Claiming it's indivisible is self-contradictory. Furthermore, even if God made atoms resistant to division by creatures, God couldn't have limited his own power. So divisibility remains inherent in matter by its very nature. This argument worked against older atomism, but contemporaries like Gassendi pointed out a weakness. It assumes God can't simply make atoms truly indivisible by supernatural power. Descartes' focus was on natural divisibility, while the atomists were talking about a fundamental limit imposed by nature or God. Despite rejecting atoms and the void, Descartes shared the mechanistic spirit of atomism. If body is just extension, then everything physical must be explained by size, shape, and motion. This naturally leads him to reject the scholastic substantial forms. Why? Several reasons. First, parsimony. Why posit extra entities like forms when size, shape, and motion seem to do the job? Second, ignorance. Descartes often admitted he didn't really understand what forms were, calling them chimeras or philosophical beings unknown to me. Third, sterility. He contrasted his fruitful mechanical approach with the uselessness of scholastic terms like occult qualities. But the deepest reason ties back to mind-body dualism. If mind and body are distinct, and body is purely extension, then forms, which the scholastics used to explain physical behavior, must be mental constructs, ideas we impose onto matter, not real features of physical bodies. They belong in the mind, not the world. Now, let's be fair. While Descartes presented a strong case, there are weaknesses. When he says he doesn't understand forms, his interpretation of them as tiny minds seems pretty specific. And while he championed the mechanical philosophy, claiming it could explain everything, history shows that was quite optimistic. Size, shape, and motion turned out to be less universally explanatory than hoped. More fundamentally, his argument against forms relies heavily on the mind-body distinction. Showing that forms must be mental doesn't automatically eliminate them, unless you can prove there are no other minds besides humans and angels. Descartes tried to tackle this for animal souls, but even there, he admitted, his arguments were only probable, not certain. The door arguably wasn't completely shut on forms. If body is just extension, how do we get a world full of distinct things? How do we distinguish one piece of matter from another? Descartes' answer lies in motion. Since all bodies are fundamentally the same kind of stuff, extended, motion is what individuates them. It's the difference maker. Motion isn't just a phenomenon. It's central to explaining how things work, determining size, shape, and governing all interactions. It's the engine driving the Cartesian universe. Interestingly, despite motion's centrality, Descartes resisted defining it for a long time. He mocked the scholastics' vague definition of motion as the actuality of a thing in potentiality, asking who understands these words. He believed motion was intuitively grasped. When he did offer a definition in the world, it was straightforward. Motion is simply the passage of a body from one place to another, occupying all the spaces in between. This is local motion, the kind geometers study. He was deliberately contrasting this clear geometric notion with the scholastics' overly broad definition, which included any kind of change, like change of form or temperature. For Descartes, only change of place counts as real motion. Later, in the Principles, while trying to be more systematic, Descartes revisited the definition of motion. He first distinguishes the vulgar understanding, motion as action, actio, by which a body passes from one place to another. Then he offers his own, more precise definition. Motion is the transference, translatio, of a part of matter from the neighborhood of bodies that immediately touch it and are considered at rest into the neighborhood of others. This definition sounds baroque, maybe even influenced by Galileo's troubles, but it's packed with meaning. Why the shift from action to transference? Descartes gives two key reasons. First, he wants to combat the common prejudice that rest is simply the absence of action. He argues that maintaining rest requires as much active cause as setting something in motion. Second, and perhaps more importantly, he wants to distinguish motion itself from the force or agent causing the motion. Motion is a mode of the body, like shape is a mode of a shaped thing. It's a state the body possesses, not the act of pushing it. This distinction is crucial for his physics, where God is the ultimate cause of motion, but individual bodies possess motion as a property. The second key difference is replacing place with neighborhood. Why? Because place is relative. Am I moving or stationary? It depends if I look at the shore or the boat I'm sitting in. But neighborhood refers to the bodies that are immediately touching the object. At any given moment, a body has only one set of immediate neighbors. This provides a seemingly objective basis for defining motion. If a body moves away from its current neighbors, it's in motion. This avoids the arbitrariness of choosing a reference frame and aims to establish a genuine, non-relative difference between being in motion and being at rest. But hold on, there's a snag. If motion is transference and transference is reciprocal, if A moves away from B, B moves away from A, how can we say one is moving and the other is at rest? Isn't it arbitrary? Descartes tackled this in a marginal note. He distinguishes between two senses of motion. Absolutely, the real part is the mutual separation between bodies. Relatively, which one we call moving and which at rest is a matter of perspective, like choosing a coordinate system. However, for a single body, motion, its separation from its neighborhood and rest, its lack of separation, are genuine opposites. So, while naming the moving body might be relative, The state of being in motion versus at rest for a body and its immediate surroundings is an objective, non-arbitrary fact. This preserves the explanatory power of motion in his physics. So, wrapping up Descartes' physics, it starts with the radical idea that body is nothing but extension. From this, he builds a mechanistic world explained solely by size, shape, and motion. This leads to denying the void and atoms and rejecting the scholastic forms as mental constructs. Motion itself becomes a central, carefully defined concept. It was a bold, systematic attempt to replace the old physics with a new, mathematically rigorous, and mechanistic worldview, setting the stage for much of modern science.